Consider the situation where we're given current and voltage and we want to determine the capacitance of our capacitor. Say our current and voltage are given by the graph below. For us to determine the capacitance of our device, we first have to recall our constitutive equation. The current running into our capacitor is equal to capacitance times the time rate of change of our voltage. Or we can say the time rate of change of our voltage is equal to 1 per our capacitance, the integral from t0 to t of I of tau d tau. For us to evaluate this, we need a time interval with a non-zero current and a dynamic voltage. That is, we are going to select the interval of 1 and 2 seconds. We can say our change of voltage, v of t minus v of t naught, that is, our voltage evaluated when t is equal to 2 seconds, less our voltage when time t is equal to 1 second, is equal to 1 per our capacitance, the integral from t0 to t of I of tau d tau. Our voltage at t is equal to 2 seconds is equal to minus 1 volts, less our voltage at t0, i.e. when t is equal to 1 second, is minus 3 volts. This quantity is equal to 1 per c of our current, which is 0.05 amps, integrated with respect to tau, evaluated between the bounds of 1 and 2 seconds. Solving for c, we find our capacitance is equal to 25 millifarads.